Okay, that's the recording finally started. Everything seems to be very slow this morning. That seemed to take an age. So we're moving on today to talk about other types of ways that you can document business processes. Now, as you know, we've been going through from the beginning, from moving into a business to trying to understand it, to trying to document what goes on and think about how that might be improved. What we're going to do today is continue that process. So up until now, pretty much everything that we've done has been suitable for both businesses and the analysis side. The one that we're moving on to today is more about the analysis side. You may have come across it before if you've done previous modules about things like use cases and data dictionaries, but I know that not everybody has done that. So that's what we're talking about today. We're going to talk about use cases, data dictionaries, and setting up classes and how they relate to each other. And again, the things that we are doing today are the sorts of things that I'll be expecting to see in your submission. Speaking of submissions, the individual presentation marks have now been calculated and hopefully posted so somebody can check that they can actually see them. I hadn't actually pressed the button to calculate it apparently. So I've done that now, and I will give you the group ones this afternoon. Okay, so without further ado, let's talk about use cases. Now, when I'm going through these things, I'm going to jump. I'm going to jump quite a wee bit. And the reason I'll be jumping around within the presentation is it's one of those things where it's all very well for me to say, well, you do this and you do this, but it doesn't really mean much. So what I have in the presentations are both the explanations and examples. So what I'll do is I'll tell you what we're doing, but then I'll go through the example and I'll probably jump back then to the explanation because that's when it will start to make more sense. And when you're coming back to look at this, that's probably the way you should do it as well. So as I said before, some of you will have done this if you've done previous modules like object-oriented analysis. This will be familiar to you, so this will be a revision. And indeed, some of the stuff that you see is actually straight from that module. Michael kindly let me take his stuff and reuse it here. And now that I say that, I realise that probably you guys don't know who Michael is because he retired a couple of years ago. But if you're out there, Michael, thank you again. So what we're doing, we are looking at business processes. We're trying to understand what they are and who's involved. And it's about the interaction. I am booking a room. I am ordering a cup of tea. I am booking my car into the garage. I am booking a service. Whatever it happens to be, you have to figure out what those use cases are. And that's what use cases means. How is your system going to be used? In what ways? How is it going to be used? So you're thinking about all the different ways that it could be used, all the different scenarios that are around making something happen. So all the things that the business does, how is that going to work? And it could be something as simple as that. You're sitting at your computer, as a customer, you go onto a website and you place an order. And you can see that we've got the customer as a stick person and the system as an oval there. And you can see how non-specific it is. So you could be on Amazon ordering a book, or on KFC ordering a bucket, or any website at all. The point is you go on and you order something. That might be slightly different in, for example, your case study. You might go online to Greg's to order a cup of tea. But if you're doing it in the coffee shop, you have to talk to somebody. So there's suddenly two stick people. The customer talks to somebody who takes the order and then places it. So both things end up being the same, but there's different people involved and there's different processes involved, and that's part of what you have to think about. And there might be different ways of reaching the same conclusion. If you're ordering a new fridge, you might go online to Curry's and order it like this. Or you might go into the shop and order it like this. Either way, you're getting a new fridge and it's from the same shop. But there might be different ways of doing it. So at its most basic, that's what use cases are. All the functional requirements in a system. Now, we've got more than stick people and ovals to do, so one of the things I want to talk about today is how these use cases fit together, and all the different bits that might be in there. So we've got symbols like actors, so people that are actually involved. We've got the thing that's happening in an oval, and we've got connections between them. And the connections are important. In that example I gave you, there's no line from there's no arrowhead rather from the customer to the order clerk to say, I am placing an order with the order clerk. Similarly, there's no line there's no arrow from the order clerk to say that they are sending back the cup of tea. There's just a connection. Arrows and use cases are very specific use. They're called include, extend, and generalize. And this is what I was talking about earlier. I'm not going to even attempt to tell you what these are yet, because we're going to go through an example, and hopefully that example will be a much clearer idea of what these are. So we've got lines with arrows, and dotted lines with arrows, all meaning different things. So we've got actors. Often they are people, but actually they can be job titles. So we could have put in Sally as the customer, but it gives me customer. Similarly, we could have put in Sally as an order clerk, but it makes more sense to put the job title instead, whoever's actually performing that function. But it could actually be something, a bigger unit. It could be a whole organization. If you send in your council tax bill, the actor could be the council. You don't know who it is or which particular person, and you don't really care. It's just the council is an actor in this relationship. And as long as there's a you and the council and your bill going from someplace, your payment going from one place to the other, it doesn't really matter. So it could be whole organizations, or it could actually similarly be systems. If what you're doing is going online to place an order, and that order is a flight somewhere, back in the days when we would take flights somewhere, you could be talking to a system that actually records what flights are available and how much they are and all that kind of stuff. So actors, even though they're shown as people, may or may not actually be people singular. They could be other things too. And of course, they might interact in lots of places. The same customer might be booking a room, booking a table in the restaurant, buying a cup of tea. It could be anything at all. So they could be the same people interacting in multiple different ways with the organization. Whether they are giving information, here's my name and address and credit card details. Whether they are getting information, okay, you're booked on the 4th of March until the 6th of March, 2 nights, breakfast included, and you'll be in room 164. So we have actors and we have use cases, things that are happening. So we use something called structured English. In other words, we try and make it as formal as we possibly can. No flowery language, no descriptors in there, just this is what's happening. And we talk about things being strong in terms of the description, particularly strong verbs. And you can see an example on there. It's not the lion is fighting with a zebra. That might be strictly true, but it doesn't particularly describe the use case that well. It's more likely that the lion attacked the zebra. So you should think about that when you're creating your use cases. Make it really clear what's happening. It's not a room was booked. The user books a room. So make it really clear what's going on. And particularly in your action words, your verbs, the thing that's actually taking place. Make sure they are really clear. Then you'll have the connections between them, and that's the lines. And they might go from actors to cases, actors to other actors, or whatever. So I realise that doesn't make much sense out of context, so let's try and place it in context. Let's give you some examples. And here's one that you've seen before: the customer, the actor, placing an order. So nice strong verb. What are they doing? They are placing an order, a verb and a noun. You know exactly what's going on. It's not specific. It's not saying they're ordering a cup of tea or they're ordering a cake. They're placing an order, whatever that order might be. That might be extended to actor interaction, who then interact with the system. So what do? You have to start thinking about the system, and that's what we've been doing over the past few weeks. We've been thinking about the systems in the hotel, how they work, what's required, all that kind of stuff. Where you weren't sure, you got to ask questions about it and speak to the employees about what went on. From that, you can start to think about who's involved. So customers clearly involved. But you might want to think about actors a bit more formally. So you might have written down Kirsty takes reservations for the hotel. Well, she might. Kirsty's on the reception. But actually what you want to write down is the receptionist takes bookings. Because Kirsty's clearly not there all the time. If someone else is on the front desk, they'll take the booking. So it's a receptionist. Even receptionist might not be the appropriate term. Because we've established that even though she's on the front desk, Kirsty does lots of things. She helps out at the bar. She helps out if there's a rush in serving. She might come away from the front desk. The manager might step in. That's where you need to be careful of different ways of thinking about the same person. So somebody might get paid. The person that does that, as far as the accounting department is concerned, is an accounts clerk. As far as HR are concerned, it's a wages clerk because they're doing the specific job of paying the wage. But they're the same thing. They're an alias one for the other. But those aliases don't always go both ways. So the wages clerk is an accounting clerk, but the accounting clerk may not be a wages clerk. So you have to be really clear about who does what and whether they have other functions as well. So you have to figure out who's involved. You have to figure out what's going on, the use cases. What will these people be doing? What's their job day to day? What actions will they be carrying out? And once you've figured that out, you can start to draw the diagrams. And of course, this helps the systems analyst who's creating the system start to create a system that will allow these functions to happen within our system. So you can start to connect the things. Now, the reason I was pointing out the arrows is we're not showing sequence here. We're not showing customer comes into shop, customer speaks to order clerk takes order. We're just showing that there's a connection. That's why there's no arrows. There's some other things as well, so we might add in extra things just to simplify how the drawing is shown. And we'll also have something called a system boundary. So basically inside and outside. So inside the business, system boundary. Outside, all the people that are involved. So systems inside, people outside. And again, I refer you back to my earlier comments. I know that doesn't make much sense, so let's think of an example. So the example here is an employment agency, and you feel free to read that. But for an employment agency, we have a few things. We have employers who want staff. We have people who want a job. And we have staff in the employment agency who exist to put those things together. We've got information in there on the sorts of information. Can someone give me a virtual thumbs up or something if I'm back now? I seem to drop off there for.
You're back.
Okay, so we'd identified the actors. We need to then think about the systems. So if we've got people that are looking for a job, well, there'll be systems about registering. Name, address, previous experience. There'll be registering jobs that are available. Who the employer is, what the job is, what is required to do that job. So what we've got here is a whole bunch of text in the same sort of way that you got a whole bunch of text in your case study. And then we can, from this text, start to tease out who's involved and what they do. And here might be a first pass at that. So we've got Firstly, that system boundary I was talking about. So that rectangle in the middle, coloured in yellow, is a system boundary. So systems inside that, people outside. Who are those people? Well, we did mention that we are going to have applicants, people who want a job. So they'll wander into the employment agency and speak to somebody who registers their details in the system. We will have employers who speak to somebody about registering new vacancies, and they will register those posts. But employers don't just talk to the person who knows about new vacancies. Applicants will also talk to that person. Anything new for me today? So they talk to each other. And in the same way, it's not just applicants that register, employers register. So they'll firstly register that they are an employer, and later they'll register each of their posts. So this is our first pass at registering applicants, registering posts, and recording who gets a job. So it's a fairly simple system. We might want to make that better at some point. Any questions about that one just now before we move on? Okay, in that case, another example. In this case, we've got an ATM. So same kind of idea, lots and lots of text that talk about how ATMs work. So I'm not going to go over it because you've all used an ATM. There is some detail in this one. So things like if you get the PIN wrong 3 times, it swallows your card, and money is only available in multiples of 10 because it's £10 notes that are in there. So again, we can take this example, lots and lots of text, and make a first pass. We've got a system where we have customers who make transactions, and we have maintenance who maintain it. Again, it's a very early first pass, so we might want to think about putting some more detail in there. Okay, if everybody's happy with those, let's think about how that detail might work. And that's where I come back to those things that have arrows on them. We might want to think about things that happen for everybody. If you come up to the ATM to make a transaction, you enter your PIN to verify that you are who you say you are. But actually, so will the maintenance people. If they want to maintain the ATM, they also have to give their PIN, their password, their access credentials, however you want to say it. Now, presumably the system, the actual system thing that checks those credentials is the same bit of system. So here we're talking about a system where it's something like a shop. If that shop wants to change the price of an item, then we don't just let them, we have to check a password. Similarly, if we're not going to stock an item anymore, we want to check the password. In other words, anytime we want to do anything on our system, we have another piece of functionality called check password. So both of these things include the check password functionality. In other words, this is one thing. Checking password is one thing that we do, but other things include it. And again, any of you that have been involved in computer systems know that's exactly how we approach them. We factor out functionality and make specific modules to address that functionality. So that's include, and you can see that's a dotted line with an arrow, and the arrow is pointing to the functionality that's included, in this case, check password. Everyone happy with that? Okay, so include are common behaviors. Extend are optional behaviors. So, for example, you have a system that's working in your shop to sell things, and you sell a Curly Wurly. Somebody comes in and buys a Curly Wurly, and your computer system takes note of that transaction and says the number of Curly Wurlys in stock has now gone down by 1. You're aware of how long it takes you to get new stocks of Curly Wurlys. You are aware of roughly how many Curly Wurlys you sell in one day. Therefore, you can calculate at which point you need to reorder Curly Wurlys to make sure that you don't run out. So the act of placing the order for a Curly Wurly will always happen. Sell Curly Wurly, take cash, decrement stock by 1. But at some point you might trigger a limit. So extending the place order might be a reorder function. We're dangerously low on Curly Wurlys, it's time to reorder. So that doesn't happen every time we place the order, but it's connected to the place order because we do it because we know that stock is going down. It's optional, but it will happen in relation to the placing order part. Make sense? John's asked a question about generalization, about common behaviors. And that comes from here. Generalization, include is common behaviors. Now, the question is it the majority of the time or all of the time? And the answer is it depends on the system. So, for example, I gave you the ATM one. You will always have to enter your PIN to use an ATM. But in general, you don't re-enter the PIN for every part of that transaction. So you might go to the ATM, enter your PIN, and then you might ask how much money you've got. And following that, you might take out some money. So you enter the PIN once, so it always happens, but it doesn't happen with every transaction, every system transaction, because there are 2 system transactions there, one to check your balance and one to take out the money. So it will depend on the system and it will depend when you need to do it. Similarly, the example on the slide was about a password. If you go on to Google Mail, you must enter your password to log into Google Mail. But every time you send an email, you don't have to enter your password again. Once you're logged in, you're logged in. So it will depend how you're setting up your system and what you want to do. I have seen banking systems, for example, that I log into, but if I say something like transfer £1,000, it will ask for my password again, because it's decided that if I'm transferring such a large amount of money, They don't want to take the chance that I've logged in and wandered away from my computer and someone else has just thought, fantastic, get in there, transfer some money. So it absolutely depends on the system. You need to decide what the system does and what the system should do. And they may not be the same thing. That makes sense, Sean? Okay, in that case, the final one is generalization. And that's ones where we can take information that applies no matter what. So you guys are enrolled in the university. Most of you are full-time students. Some of you are part-time students. Doesn't really matter. As a student, you'll still have some information that's stored, your name, your address, your phone number, the modules that you're taking. So there will be a common functionality in enrolling you as a student. But there will be slight changes depending on whether you enroll as full-time or part-time. Maybe something simple like if you enroll full-time, you'd need to take 3 modules per term, and if you enroll part-time, you take 1 module per term. It doesn't really matter. You've still got, as I say, your name, your address, your phone number, your email address, the name of the modules you're taking. All of that enroll stuff all stays the same. But there's a slight difference in terms of the fine detail of what you have. So we can generalize out some of these things. And again, if you've been used to doing programming, that won't be news to you. Now, there's sometimes a confusion between include and generalize. Include is about the use case. Generalize is about the data. So you include things because it's about what you're doing. It doesn't matter what the price is, what the item is. We don't care what the data in this case. We still want to check the password. For the student, it's the data that's similar. Name, address, blah, blah, blah. So include is about a relationship with the use cases. Generalization is about the data being similar. That makes sense? Okay, so don't forget there is no sequencing in use cases. So for our university example, there's no sequencing in terms of approve result and then notify the student of the result. Approve results is one use case. Notify the students is another use case. There's no this then happens after that. You guys know that more than anybody because your results were approved, they were marked, and I forgot to notify you. There's no sequencing. Okay, so we have our system. We've tried to figure out what goes on, and then we can start to think about how we simplify the use cases. And it takes into account all those things that we've just talked about. We think about all the common things that go on, like entering a PIN or a password, all the similar behaviors or common behaviors or data that can be reused. And again, because this is so tightly bound to programming, the same sorts of things happen with programming. Specifically, that there is a balance point between making lots of really small use cases that are really clear, but you get lots of them, or something a bit more complicated, which will lead to a cluttered diagram, but takes in more of what you're doing. That's again about experience, about understanding both the system and how it will be implemented. But it's about finding that balance point. So there's some suggestions up there about how you can avoid cluttering your diagrams too much. But let's go back to our examples and let's see if we can figure out ways of making them slightly more helpful. So let's, for example, factor out the common functionality. So let's think about our employment agency. We talked about registering. We're registering applicants and we're registering posts. Well, isn't there something common to those? Presumably you want the applicants to have the skills necessary for the post, and the post clearly lists what those skills are. Maybe there's something that has a match in there, so we can look at the criteria for both the applicant and the post and see if they match. So that will, the registering the post and the registering the applicant will both include the matching criteria. Do they have the skills that we're looking for? We can also do things like factoring out any functionality that's the same. So here it's our ATM example. And I've already said that if you log into the ATM, either as a customer or as a maintenance person, you're going to have to identify yourself. So the entering PIN part is presumably going to be included in both our make transaction and maintain ATM use cases. So that's the first thing we might want to think about. Second one we might want to think about is getting a receipt. Again, if you've used an ATM, you'll know that one of the options it gives you is get your money or get money with a paper receipt. So if you get the money, that will always happen, but you won't always get a receipt with it. So that extends make transaction. So making transaction includes getting the money and will sometimes be extended to include getting a receipt. We also might want to look at those transactions. We're just saying make a transaction, but there's different things you could be doing. Making a deposit, making a withdrawal. There's lots more, but we'll keep it simple for now. So we can move on from this very simple use case diagram to something more like this, which is actually closer to what we have. So we still have customers making transactions and maintenance maintaining the ATM. But we've thought about how we get access to it. We check the credentials, the PIN, and both make transaction and maintain ATM include checking the PIN. Make transaction is fairly general, so yes, we will always make a transaction, but it might include making a deposit. It might include making a withdrawal. Why are they included? Because you could be doing both. You could be depositing a check and withdrawing some cash. So the making transaction might include both of these. And then when you're done, you may or may not extend that make transaction to get a receipt for everything that you've done. So we have multiple use cases with includes and extends, just in that very simple example. You happy with that before we move on? Okay. So once you do that, you start to go through and check your diagram. And again, I'll not read out these things because they're there. Refer to them when you're making your diagram. Most of them are fairly clear. Use a noun and a verb, make transaction, enter PIN. Think about the commonality, think about the includes, think about the extends, and think about how that works in terms of the system. Think about generalizing. Don't cross lines because it's impossible to follow. If you need to put in the same actor in a different place so you avoid crossing a line. Don't show sequence, and remember that actor names are singular. Customer, not customers. Any questions about that? Okay, if there's no questions, that's the end of the use case one. We've got a couple of these things today because they all come together. So we've got use cases, data dictionaries, and classes. However, that I think is probably time to take a break. So we take 10 minutes and I will see you in 10. Everybody's fallen asleep. I'll see you in 10. Right, and we're back. Hope you managed to get a cup of tea, because I didn't get the time to make one. Anybody thought of any questions while we've been away? So the question in the chat is, do we get to meet with anyone again? So you know that I haven't specifically set those up, but part of what you need to do as a business systems analyst is decide what you want to happen. So if you want to meet with somebody, I suggest you get into the channel and start requesting a meeting. And if you do that, then it can happen. So I want you guys to take responsibility for this rather than it going via me, in essence. It is a good thing you asked. I've been wondering when somebody would. Anything else? Okay, in that case, our next one is moving on from use cases, but as part of use cases, we were talking about data and similar data. And of course, if we're going to store data on a computer system, we need to know what that is and what type it is. So one of the things that we want to do is have somewhere we can store a description of all the data that we will need for our system. And that's called a data dictionary. And we'll be setting up our data dictionary to have all that information. So thinking back to the last one, information about the applicant, their name, their address, their skills. How is that data saved? The employer, their name and address, and their job. But of course, if they might have multiple jobs, so you might need to store multiple versions. So we'll look at how we get that information and how we go about formalizing it, because the formalization, of course, is important. When we are setting up a system, we need to know what that data is, what type it is, so that can be set up in a system. So we need to, first of all, figure out what our smallest pieces of data are. And those are called elemental data, elementary data. Something that's so small you cannot make anything smaller. How many Curly Wurlys did you buy? 6. I mean, clearly not enough Curly Wurlys, but it's still the quantity of Curly Wurlys that you bought. Can't go any further. Now, you might have been an order as part of that. What did you buy? Curly Wurlys. Quantity 6. And we'll talk about that when we talk about composite data. But the elemental data is stuff that you cannot subdivide. So something like quantity. Now, just like with the use cases, we have some rules that we have when we're naming these things. And the reason we have these rules is so that people can understand very quickly what it is we're talking about. If we all make up our own words, we don't understand each other. So we set up some rules around these things so that we can pass them on to different people and we'll all understand it. So if you have things like account balance, you don't run them together, you put an underscore between them. If you have specific pieces of information that may be ambiguous, if you have a date, for example, you don't just call it a date. Think about what it refers to. So you get order dates and invoice dates. So just be really clear about what the data actually is. Once you've thought about that, then you can define how that information is stored. So we've talked about the names. So there's order date, for example, with an underscore. But what is that order date? What format is it? If you're in Japan, it will be 20220304. For 2022, 03 is March, 04 is today. In the UK, we tend to use 04, 03, 2022. In fact, quite often we put slashes between the day, the month, and the year. If you're in America, it goes month, day, year for reasons best known to them. Doesn't matter what the case is, you need to note that somewhere and decide that that is how you are storing the date or whatever else it is. Because other things may also have meanings to them. You may have a quantity. How many Curly Wurlys did you buy? 1, 6, 20? What's the range of it? Is it likely that anybody will buy more than 1,000 Curly Wurlys? Well, if not, maybe you want to do a range so that you don't accidentally type in something that you didn't mean to. How many did you buy? 1. But somebody looks away and they've kept their finger on the 1 key and it suddenly says 111111 and somebody suddenly bought 111,111 Curly Wurlys. Putting ranges on it helps that kind of error checking. You may also decide to ascribe values to particular things. So the example there is marital status. And you could fill it up by saying things like married or single or divorced. Or you could say, well, actually, we can save in some data space here and save in some entering time by just saying S or M or D or W. In the end, that's down to you. But as long as it's defined and as long as everybody agrees, everybody can use the same thing. I definitely want a Curly Wurly now, so feel free to send them to me. The other one about elemental data is it may be shown as different things in different places. So if you're working in a business, in a factory, in some places for HR, it might be known as a staff number. For the accounts department, it might be the payroll number. For logging in and out to the factory, it may be a works number. They're all the same thing. So you need to know that they're the same thing and show that they're the same thing somewhere. So that's elemental data. Those then get put together to create composite data. What did you buy? Curly Wurlys. Not Kit Kats, Curly Wurlys. I mean, I'm fond of a Kit Kat, but it doesn't compare to a Curly Wurly. How many did you buy? 6. That's an order. So that's composite data, and that goes in uppercase. So the elemental data goes in lowercase, the composite data is in uppercase. So again, just like last time, it's an awful lot easier to show an example. Now, quite often what you'll be doing when you're creating these things is taking information that exists on a paper-based system and translating it into a computer-based system. So you might have something like this on a bit of paper. And you can see here that it's a list of results. We have an exam, which has a reference. We've got the name of it. We've got the date that it took place, and we've got all the people who took that exam, identified using the banner ID and their name, the mark that they took, the result that they got, and whether they got a distinction. So that's the bit of paper. So what would we do if we want to put this into a computer system? That's called data decomposition. The first thing we do is we list everything. What is on there? Think about all the things that are in there. It's called a results list. There's an exam reference, there's a title, and so on and so on. Once we've listed everything, we figure out the things that are repeated. So in this particular case, we're looking at the individual results. This is the same data. just repeated and repeated. We've got things that might be selected. Now, when we were talking about this, we used single, married, whatever. In this case, the exam reference might be selected. Clearly, we will have a list of exams that are taking place. So rather than have somebody type in COMP 08033, why not have a list of them and you select from it? And the final one is we have optional data. In this particular case, it's this distinction column. If they get a high enough mark, they pass with distinction. If they get enough that they pass, they get the pass, but they don't get the distinction. So we have repeated, selected, and optional data. So we can start to think about how we're going to set those up. We can start to think about the related items, a single result in this line, for example. And we can start to think about those and how we are going to store them, and might want to think about using the same prefix for particular things. So order underscore number, order underscore date, order underscore customer ID. All of those things help to put all the data together so that if you see it, you understand where it's coming from. Now, sometimes to help create the data, you might end up with intermediate pieces of data. So, like I said, a result. And we also have some punctuation to show how these work. So I'm not going to cover this, I'll come back to this, but again, I'll do it with an example. So here's our example. We have a results list, and the first thing we said was we are going to identify everything that's on there. So our results list is an exam reference and a title and a date and a banner ID and a name and so on. So that's what we have. We have a results list, which is an exam reference, plus an exam title, plus an exam date, and so on. And you can see that we've followed the rules that we set up for ourselves. The composite data is in uppercase. The elemental data is in lowercase. And if there's more than one word, we put an underscore. And we've said that this data all works together by using this plus here. So this is a sequence. Plus is used to separate data items. So that's our first step. We've identified everything that we have on there. Next one. Is there anything in there that gets repeated? Well, yes, we've got all these things, all these single results. So starting at banner ID and ending up at distinction. So we've got some punctuation for that. Starting at banner ID and ending up in distinction, we use curly brackets or braces or whatever you want to call them. That represents repetition. Okay, so anything between the curly brackets is repetition. We have a choice. The result could be you pass or you fail. So the choice is in square brackets. And the choices that we have, we use this vertical line between them. So this is called selection. Discrete data items with square brackets and a vertical line to decide what our options are. We've got a result and it could be either pass or fail, nothing else. And we've already used curly brackets and square brackets, so our final one is normal brackets. That's an optional one. You may or may not have a distinction. So anything that's optional is a curly bracket. We know it's optional, not everybody gets a distinction. Okay, so we start off with everything. We then start to figure out which bits are repeated, which bits have specific options that we can choose, and which bits we don't always have. So then we can start to split those out further. So in essence, what we have here is a results list that's got the bits before the curly brackets and the bits after the curly brackets. In other words, we've got the exam reference, the exam title, and the exam date. So we'll call them the exam details. And all the stuff that's in the curly brackets is the student result. So we can start to make more bits of data. Student results consist of this information. Exam details consist of this information. So our results list consists of the exam details plus as many students' results as you require. Does that make sense? I appreciate that you need Curly Wurlys to understand this, so I hope you all have them. David is out of luck apparently. I hope the rest of you have them. I am also out of Curly Wurlys, and I may have mentioned that, you know, if you want to send them to me, I'm happy. We okay with that? Can I move on? Okay, so continuing the theme, we have results for an exam. Now, if you've ever sat in an exam, you'll know that you have invigilators. You have people wondering about checking that you're not cheating. So we have a bit of paper that gives us the invigilator list. And again, we can start to take this bit of paper and start to create our entries in the data dictionary from it. And the first thing we do is try and figure out what the elemental data is. Exam reference, name, date, invigilator name, department, phone number. That's individual stuff. We've got some things down here. Each exam has a minimum of 2 and a maximum of 4 invigilators. So that's something else that we need to remember and take note of. But we can go through the same thing. Invigilator list is all of these things, straight from this bit of paper. So we can also look at that and decide, okay, well, is there anything we can do with this? Well, yes, these things clearly are repeated. So they go in our curly brackets again. But we had some other information. Minimum of 2 and a maximum of 4. So we can take a note of that. We can simply put a 2 as our minimum limit and 4 as our maximum. You might have data that says how many people are in the room. If it's a family room, it might be up to 4. If it's a double room, it might be up to 2, but you store the name of each person that's in there. Okay, so the invigilator list gets here. We then start to do what we did with the exam list, and we notice some things. Not surprisingly, the information about the exam on the invigilator list is the same as the information about the exam on the results list, specifically the exam reference, the title, and the date. So we can say, oh, that's fine, we've already got an exam details. We'll reuse exam details from the results list and create a new one called invigilator details with all their information in between 2 and 4 of them. So as we approach this process, it helps us understand what the data is, but it also helps us to understand where the commonalities exist. And that will help us understand how the information is related. Everyone happy with that? Okay. So the next one is from our job example. So it's the same kind of idea. Here we've got an application form with information. So that's from the people that want a job. And we've also got the post information, people that are offering jobs. And we start decomposing again. The application form, we go through it and we find all of these things that are on the application form and we write them down. And then we think to ourselves, okay, anything the same, anything different, anything that repeats. And clearly people might have had lots of previous jobs. So the job title through to end date and salary might be repeated. So their name and address don't change, but they might have had lots of previous jobs. So our application is the applicant details plus the job details. So we can start to create information. That then goes into the data dictionary and can be used by anybody who's needing to use that information to set up any systems. Same thing with the post. We start to write down everything. Company name, address, post title. But of course, a company may have more than one post available. So that goes into our repeating part. And then we can start to extend that out and say, okay, we'll take the bit that's not repeated and the bit that is repeated and we'll make them separate names and we'll call them company details and post description. Okay, so it's fairly logical. We go through what's required and we try and understand how the data is put together. Once we have all that, we're going to put it into our data dictionary, and that is an actual document, like a dictionary. So we can go to the data dictionary to look up what we need for all of these things. So if somebody says, what's the company details, we go to our dictionary and look up company details because it's under C and find out that company details consists of company name plus company address. So you will create a document with a data dictionary. It's a data dictionary document. It will have all the documents that you used to start creating the data. It will have the composite data and the elementary data, and you arrange it in alphabetical order so that everybody can go and see what data you want to use and what it's talking about. So anybody that's involved can go and read that. So you start off having a document list. And then you start to think about what you use to create that. So the document that you had was the invigilator list. And from that, you have made composite data called invigilator list. The document was result list. So your composite data is results list. What composite data is included? Well, we set up exam details with that information. We'd set up invigilator details with that information. We had an invigilator list, which we've talked about at the top. There's composite. Invigilator list is exam details plus invigilator details. Minimum of 2, maximum of 4. Similarly, our results list is our exam details plus a student result. Well, we haven't put down student result, but that's okay because this is in alphabetical order, so student result comes after result list. So our student result is there too. So we can look up everything in our data dictionary and understand what it is. We will also have lists of our elemental data with all the information that we require for it. So the department is up to 10 characters. What department? Well, that was in our invigilator details. It was one of our pieces of elemental data, remember? The department is up to 10. We've got a banner ID, so that goes before department because it comes before it alphabetically. The format is B followed by 8 numbers, so it's got a size of 9. It looks like my columns are out of sync, and I apologise. Next piece of data, distinction, that comes after department, and it's got 1 character, and it's just Y or N. Exam date, we are going for day, month, and 2 digits for the year. exam reference has got 9 characters, COMP 09001, 9 characters. Exam title's got 80 characters, and it's also sometimes known as the exam name. So in the results list and the invigilator list, it was called something slightly different, but it's the same thing. Invigilator name's 60, the phone number's got 4, the mark is a size of 3, and because it's a percentage, it can only go between 0 and 100. The result is either a pass or a fail. That's clearly 4 characters, and you can choose one or the other. And we're reserving 60 characters for the student name. So in the data dictionary, you can go and see all this information, and anyone can pull it out to understand what's going on. Any questions about data dictionaries? You're all very quiet today.
Well, personally, I've not been feeling well, so that's my.
Sorry to hear that. All right. If there's no questions, we'll get some more stuff to do, but we'll take a, not as long this time. We'll take 5 minutes, quick comfort break, and I'll see you back in 5.
Cool.
All right. So we're back from our quick break. I realise it's been quite heavy today, but that's partly because it's, for many of you, this is revision. I'm aware that you've done this before. Not everyone, but hopefully those that haven't done it will get help from the other people in the groups that have done it. And if you haven't done it at all, then hopefully this will give you enough to do it. All right, so the next thing I want to talk about is the next thing on our journey from business friendly to systems analysis friendly documentation. The next thing is something called class diagrams. And again, if you've been doing any sort of programming, you'll understand about classes and objects. But for those of you that don't, it's our next move. It's our next one from everybody can understand it, but it's not very precise, through to, yeah, you need some knowledge to understand this, although you can pretty much make out a lot of the things without a lot of knowledge, but incredibly accurate in order to allow you to create the systems. So we've created data dictionaries, we've created system descriptions. So what we want to do now is try and figure out who is involved in this. And what we're going to do, or who or what is involved in this. So to do that, we're going to create things called classes. Now, the easiest way to start thinking about our classes is to consult our data dictionary that we've created, or consult our system descriptions. So in the data dictionaries, it's all this composite data, might be an object, it might be a class rather. And the system description, anywhere you've got a collective noun. So lots of something, that may also be a class. Once we've decided on that, we'll attach things to them to describe that a wee bit more. So they look like this. So it's basically a rectangle split into three is a class. So a class is something that has similar properties. So in this case, we've got a student, and students have similar properties. There's lots of them, but we'll cut it down to just a banner ID and a name. These are called attributes. So the attributes of a class are in here. And again, if you think back to that data dictionary, that's pretty much how we set it up. Student details with a banner ID and a name. Here we've got a class called a student with attributes of banner ID and name. They also have common behaviors. If you're a student, you have to enroll. All students have to enroll. It's a common behavior. So we have what it is, their properties, specific properties, and behaviors. Once we've set up that class, we can reuse that. So a class creates an object. So the student class creates a specific object of a student. John Smith here, Mary Jones here. The student is the same, but the attributes are different. So let's extend that and let's think about other types of classes that we might have. Here we've got two called product and customer. So the product has specific attributes, product number, how much stock we have and how much it is. And here in customer, there's also a customer number. So Curly Wurlys might be product number 1 in our system. and Joe Blogs might be customer number 1 in our system. The attribute you see has the same name, but it belongs to a different class. So that's how we can tell it apart. Similarly, the things that we do to these classes might be the same. So we might update a stock level for a product. We're not going to update a stock level for a customer. Or we might update the price. Again, we wouldn't update a price for a customer. But we might want to display the product. So we might have information about that product, a picture of a Curly Wurly, a picture, an information about who we get it from, how much it costs, all that kind of stuff. And we might also display a customer, picture of the customer, their name, their address. So as with the attributes, we might have something that's the same name, but they will do something different. For the product, it displays the number, the stock level, and the price. And for the customer, it displays the number, the name, and the address. And we've got a fancy name for that. It's called polymorphism. So the display functions are polymorphic. When we are implementing those, when we are implementing the display for the product or implementing the display for the customer, that's called a method. Okay, so that's classes, attributes, objects, methods. So now we can start to think about those things. We need to abstract it. We need to think about what it is and what it does before we decide to set up the class. And we also need to think about what it consists of and what we do with it. So we display a product, we display a customer, but how we implement that, the internal implementation of that, is going to be different, clearly. So classes will have things that they show other objects in the system. That's their interface. But internally, they'll have how they implement that. So products will say, yeah, if you want me to display, just tell me to display. And customers will say, yeah, if you want me to display, just tell me to display. But internally, how they actually display that will be different because they're displaying very different things. Sometimes you want to put things together. So you might have a class called student, and a class called invigilator, and a class called exam. And you might put all of those together to give you a specific exam. That's called encapsulation. No, sorry, I'm about 4 slides ahead. Ignore what I just said. When you have your object, you have a name, you have the attributes, you have what it can do. All of these things put together is called encapsulation. So the data and what you can do with it are in one thing. That's the class. Its name, how it's described, its attributes, and what it can do, its methods. So you get different types of class coming from different places. You might have things that you create from the data dictionary, products, invigilators, students. You might have stuff that comes from the system description. And you might have stuff that is internal, it's stored by the system in order to pull data together so that you can get those student lists and those invigilator lists and the exams all together. You also have stuff that you're going to need to make all this work. So you might have control classes that say how things are going to interact together. So you might have a take an order class that talks about order clerks and talks about customer details and all that kind of stuff. All pulled together, all to make an object that lets you take an order. Okay, so we've got a class with a name. We've got the specific data that describes that class when an object is created. Those are called the attributes, and the things that it does are called the methods. The attributes can be found because we've already created data dictionaries. That's a great place to find them, as is the system description. So nouns from the use case description can also be used. And like I said, you can repeat things. You can display things. Or for the attributes, you can reuse the same name. So you might have the customer name, or the product name, or the customer ID, or the product ID. So you can reuse those things, but their fully developed name will include the class that it belongs to. What you can't do is repeat that within the same class. So you can't have two names. So to create the class diagram, you start thinking about what your classes might be. As I say, you go to the data dictionary, you go to the system description. And then you think about the attributes from that. So here was our data dictionary for the job application, so the example. And we might look at this and might say, okay, so what classes do we have here? Well, clearly we've got applicants, and they might have their name and address. That might be one class. We might have the company, also with a name and address. That might be another class. Jobs might be another one with all this information. So we might end up with things like this: applicants, companies, jobs, and posts, all with specific attributes. And you'll notice that some of them are the same. The applicant has a name. The company has a name. The applicant has an address. The company has an address. That's fine, because it's the applicant name and the company name. Similarly, we can look at our system description, and we might think, okay, what might we want out of this? So it's people applying for jobs, which in this particular description is called a post. So a post might be a class. If they apply for that post, they may or may not get the job. So an outcome might be a class. So the post might have a status, available, not available, and they might have an outcome. Got the job, didn't get the job. Anybody get any questions about that one? Okay, in that case, finally, what we have is, if we have our use cases and our dictionaries all setting up our class diagrams, then presumably these classes that exist will have relationships between them. If we have classes for students and classes for exams and classes for invigilators, presumably at some point they will come together. So class diagrams have relationships. Of course they do, they interact, they work with each other, They do things. And the sorts of stuff that we've talked about before will also exist. There'll be associations, compositions, generalizations, all of that stuff that we've talked about before will exist. And we want to show that. So we want to create something called an object diagram. And it might look like this. Here we have created classes. We have got student classes, and you'll see that they have attributes of banner ID and name. We've got a module class, which has names. And you can see that there is a relationship there. Student John Smith takes this module, and this module, and this module. Student Amy Jones also takes this module, but only this module. Student Bill Brown doesn't take that module, but does take this module and that module, as did John Smith. So you can start to see the relationships. And it is a relationship. It's a bi-directional relationship in this particular case. So it's just shown using a line. The student is taking the module has a student. It works both ways. So that's called an association. But there might be more than one. A student probably takes more than one module. So for you guys, you can take up to 3 modules in a term. So we can say that students take modules, and students can take between 1 and 3 modules. But modules can also have students, and there's an unspecified number. Modules might not have any students attached to them. It might have 500 attached to them. So we can see that we can use symbols here.
Motion detected at the front door.
We can say exactly how many there are. We can say they will have a number, but we don't know what it is. We use the asterisk. Or we can give a range, and we use the 2 dots to show a range. That's called multiplicity. There might also be multiple relationships. So when you're doing your honours next year, you'll need a supervisor for your honours project, and you'll need a moderator for your honours project. So the student needs 1 supervisor and 1 moderator, but the lecturer may be supervising multiple students and maybe moderating multiple students. So there's more than one relationship between the lecturer and the student there. So that's that one. Next up, we have something called an association class. So we've already said that students take modules, modules have lots of students. But as part of that, and only because there is that relationship, there will be an assessment. So the class is attached not to the student or to the module, because you don't take an assessment on its own. You only take an assessment because the student is taking the module, and the module has that student attached. So it's attached not to the class, but to the relationship. So we have an assessment is associated with this relationship. We might have multiple role names. We might say that somebody is a lecturer, and there might be lots of lecturers. But somebody may be a lecturer, but also be the head of the department. So that leads back in. We've only got 1 department head, so we've got lots of lecturers, but 1 department head, and that is also a lecturer. We can also show that kind of relationship here. So we can say that there is 1 supervisor and 1 moderator if we're going to show that in one of our diagrams. And as we did with our other things, we're going to aggregate and have composition. So we're going to put things together in different ways. So things that aggregate can stand on their own. But compound objects have to have everything there for the thing to be a thing. Yeah, I know it's getting complicated. So here is an example of aggregation. So aggregation, the component objects may exist independently of the compound object. You go into a restaurant, you order fish and chips, or you order steak, or you order whatever. That's a dish that's on the menu. But there might also be a set menu. So the restaurant might have multiple menus. It might have a la carte. You can just go in and order whatever you want. Or there might be a set menu. You can choose either the soup or the pâté to start. And you can choose either the fish and chips or the steak for your main course. And you can choose either ice cream or rice pudding for your dessert. So the aggregation there says, well, we're serving fish and chips, we're serving steak, we're serving ice cream. They exist on their own, but we're going to create a set menu from a certain number of those dishes. We don't know how many. But we may or may not have a set menu. The dishes will still exist, but the set menu may or may not. We could have 0, we could have 1. So that's aggregation. Those dishes will still be available regardless of whether or not we've set up a set menu. Composition, on the other hand, says, well, if you don't have the whole thing, you don't have the bits. If you don't have a book, how can you have a chapter? A chapter doesn't exist on its own. A chapter only exists as a part of a book. Okay? So watch out for those when you're creating these diagrams. We can also do what we've done before and start to use generalization and use inheritance, the same way as we did with our use cases. So we have here an example from a bank. So if you open an account with a bank, it knows who you are. It's got your name. Account number. It's got how much money you have in it. It's got things that you can do with it. Deposit money, take out money, so on. But you might have different types of account. You might have savings account and business accounts. And they might add in extra attributes. So a savings account, you may get paid interest on the money that you have in there. The balance still exists. Still a balance, you get paid, but you get paid interest on that balance. How much? Well, you need to calculate that, so that's another method that we need to add in, calculating the interest based on the interest rate. What if you've got another type of account? What if you've got a business account? Well, commonly, if you have a business account, they charge you for it, either a set amount a month or a set amount per transaction. But we need an attribute to know what our charges are, and we need a method to calculate those charges. All the other things still exist as part of the account, opening them, depositing, withdrawing. So in the same way as we did in the use case, we have generalization. So we've generalized the account information, and then specific types of account can inherit that information, but add in its own wee bits and pieces. That can continue on. So here we've got an example from the university. We've got students. Students might be research students, so you might be doing a PhD and you might have a supervisor, or you might be someone being taught, so you might have courses. Either way, you've got a banner ID and a name and address and so on. But actually, taught courses might have other attributes to them. You might be self-financed, so you might have to pay for your modules, or someone else might be paying them for you. And if you're in Scotland, the government will pay your fees to be taught. So we start getting multi-level inheritance. Or we might have multiple inheritance where it gets things from two different places. You don't get them so much anymore, but there's something called an endowment mortgage. And the idea was you got a mortgage to buy a house, so they loaned you a certain amount of money, but you also took out a savings account. It's called an endowment policy. And the idea was your savings would earn so much money in the time of your mortgage that by the time it was done, it would pay off your mortgage. And the reason you don't get them much anymore is because that didn't work out and lots of people still had lots of money left to pay. Regardless, you can inherit from two or more classes. So an endowment mortgage will inherit from both a mortgage and an endowment policy. So we start to get this idea that we can start to create a diagram with all our classes, all the descriptions, all our generalizations, all our inheritance, and it starts to get quite big. So you might want to think about how you split that up as well. How might it look? Well, for our employment agency, we might have these classes we said. For our data dictionary, we have these things, which gave us those classes. So we might end up with a class diagram that looks like this. Applicants. So one applicant might have had lots of jobs, but they might only have had one or none. The asterisk doesn't tell us. It just tells us that job's a thing and it could have 0 to n, but only one applicant. On the other hand, applicants connected to jobs, well, the post might have multiple applicants, and actually the applicant might apply for multiple jobs, so we've got asterisks on both sides. The post itself belongs to a company, and there's only one company, but they might have multiple posts advertised. And then finally we've got the outcome, and the outcome only exists if the applicant has applied for a post. It doesn't apply to the applicant or to the post on its own, it's only when they apply. So it's connected to the connection, and that gives us a result of that applicant applying for that post. Okay, so we can start to create class diagrams like that. That's the employment agency one. And you remember with the ATM, we had these kinds of things. And so our class diagram might start to look like this. We have an ATM. We have one ATM that might make lots of transactions. Those transactions will take place in a date at a particular time and be for a certain amount, but actually they could be deposits or they could be withdrawals. Those transactions will be linked to a single customer. So transaction to customer, there's only one, but customers might have made lots of transactions. So there's an asterisk there. And that single customer, whenever they have done this, will have entered their PIN. So it's connected to that class. Remember we said that we had a PIN. Customer's got a PIN, maintenance has got a PIN. So the maintenance will also have a PIN, but actually there might be lots of maintenance people. And they may maintain more than one ATM. So we've got asterisks at both sides. And again, when they do that, they save a log of what they did. So it's connected to the relationship here. So it starts to get a wee bit more complicated. And depending on the system, it will get more complicated. Anybody get any questions about that? No? Okay, if there's no questions, let me stop the recording.